Hey, welcome back to Math with Patrick and Quill. Today is August 22nd, and we're solving problem number 234 from the Daily Epsilon calendar. And the answer today should be 22 because the answers for the problems from the calendar always match today's date. So we are just trying to find the positive root of this equation, which is x squared minus 2x minus 440. So when it's talking about a root, that's just some kind of like mystery number for x right here that we don't yet know that causes our equation to equal 0. So like one kind of maybe naive way to try to solve this problem is just to plug numbers in for x and see if we get a 0. Like if we try plugging in the number, say 2, we could do like 2 squared minus 2 times 2 and then minus 440. And I can kind of clearly see that this minus 440 is overpowering really anything that's happening right here, at least for now. And so this number here is not 0. Actually, yeah, these cancel out. So this number is actually equal to negative 440. Definitely not 0. And so that means 2 is not a root of this quadratic equation here. So we could just keep guessing positive numbers until we find it, right? It does say find the positive root of this equation. So we could guess 1, then 2, then 3, then 4, but maybe you can tell that would take a little bit of time. So instead, I'm going to maybe talk about quadratics for a little bit, then I'll show the strategy that specifically pertains to this problem. Essentially with quadratics, you can think about them in standard form, which looks like this, or factored form, which might look like something like this instead. And whenever you have quadratics in factored form, if you want to go between the two forms, you can just kind of distribute everything and multiply it all out. I prefer area formulas. That's at least what I like to do the most. But you could also think about like the foiling strategy where you multiply the first, the outside, the inside, and then the last terms. Either way, you should get x squared plus 4x minus 2x and then minus 8, at least for this example. And collecting up these two terms and combining them together, we get x squared plus 2x and then minus 8. So to go back and forth between factored form and standard form, to go this direction, you just need to multiply everything out. But to go backwards, it's a little bit harder. The main strategy is just noticing that this negative 8 comes from multiplying these two numbers. And then this positive 2 comes from adding the 4 with the negative 2. So like for our problem at hand today, I could maybe borrow this area model actually, and I could place negative 440 in this spot. The x squared can stay. And then I'm essentially just trying to find those two numbers that are going to add to negative 2 and then multiply to negative 440. And I mean, we both know that one of these numbers should be 22, but for now, I want to just pretend that I don't. And I usually like to think about factors of this 440. I like to think about the multiplying number first before I think about the adding one. Just because if we think about what two numbers add to negative 2, there's an infinite list. I could do like 0 and negative 2. I could do negative 1 and negative 1. I could do essentially I could keep subtracting 1 here and keep adding 1 right here. And I would just get, subtracting 1 on that side. I would just get an infinite list of possible answers. And I don't really like the idea of searching for a needle in an infinite haystack. Instead, I like to target the product, or the two numbers multiplying to the negative 440, because at least this way, it's eventually going to end. Like I could do 440 and then times negative 1. That would work. I could do 220 times negative 2. That would also bring me to this number. But then if I try adding these together, this one I'm going to get 430 39. For this one, I'm going to get 218. And again, my target for this number right here is this -2. And so I know that not only am I nowhere near the number 2, but I actually need my negative number to be bigger than my positive number. Or rather, I need the negative number to have a greater absolute value than the positive number. So I could skip over a few factors. I might be missing some right now, but I do know that like 44 and 10 obviously work. I guess let's make that negative. And, probably I could slot in a 5 right here for another valid factor of 440. But I'm really just trying to figure out what that middle part is because I want these numbers to be much closer together to produce a number closer to 2 because currently my sum is still positive 34. I could probably double the 10 and have the 44, so I'm getting 22. And then here we go. Now I've basically found it. Still adding these together, I get positive 2, and ultimately I wanted a negative 2x. So I think once I flip these around and call it a negative 22 and a positive 20, I have found the sum that I wanted. So here it could be a negative 22x. Here it could be a positive 20x. This tells me to get x times something is negative 22. Negative 22x. This up here needs to be a negative 22. And likewise, x times something is positive 20x. Well, this needs to be a positive 20. So that finally tells me I have my factored form. It's x plus 20 on one side and x minus 22 on the other. And I'm curious still when this equals 0. That's still what we're trying to find. We're still trying to find roots. I still want to know what value of x causes this thing right here to become 0. Writing it as a product is super useful because if we know something times something equals 0, well, surely one of those two somethings is 0, right? If I do like 0 times 5, I get 0. If I do like 100 times 0, I still get 0. If I do 0 times 0, I get 0. And so if I have a product and the result is 0, then I know that one of them is 0. So either x plus 20 is the 0, so I can express that like this, or the x minus 22 is actually the 0, and that's what's causing my product to give me a 0. We can do, pretty simple algebra steps to isolate our x's, and that shows me that I have two potential roots for this equation. Either x is equal to negative 20, or x is equal to positive 22. And of course, it was asking us for the positive root, and therefore the answer today is 22 and not negative 20. So that's basically the answer right there. If you already knew how to factor quadratics, then going from here to here was probably pretty quick, but I at least wanted to explain kind of the thought process of how I go through something like this. This problem would have been harder, say, if this x squared had some kind of like leading coefficient on the front. This does change my strategies when I'm trying to factor these quadratics, but I suppose I would have to save that for a different video. Anyways, the answer is 22 for today, and I'm feeling all done. So thanks for watching, and I'll see you tomorrow. Bye.